This is lesson 7.2 and college intermediate algebra, and this is called equations with absolute value. Okay, so if you remember, absolute value, the signs are like this, and if I put an x, oh, let's not even put an x there. Let's put a 5 here. The absolute value of 5 is 5, and the absolute value of negative 5 is 5. Okay? Because what absolute values are is actually the distance from 0. Okay? So it doesn't matter if you go to the left of 0 on the number line in the negative direction, or whether you go to the right of 0 on the number line. So either way you go, this direction is going to give you a positive 5, and this direction is going to give you a negative 5. But the distance from 0, either way, is going to be the same. It's going to be 5. Okay, distances are never negative. Direction is negative, but distances are not. From here to McDonald's is 5 miles. The distance from McDonald's back to here is not negative 5 miles. It's still 5 miles. It's just a different direction.
So it's the absolute value.
So the absolute value just says, how far is this number from 0? And it will always be a positive number. Okay? And it does get a little bit confusing, and hopefully we can get rid of some of that confusion as we go along here. So if you look at the first example on the bottom of page 404, is that the right page? Okay, we've got the absolute value of 2a minus 1 equals 7. Okay, first thing, this number right there, that's 7. Cannot be a negative number, can it? Because then you're saying the distance from 0, which is what this represents, is a negative number, and the distance cannot be negative. So whenever that number, that equal sign, like in this case 7, if that were negative, there would be no answer. It doesn't work. Okay? But in this case, it's a positive number, so we're good to go. Okay, so what that equation up there is saying is it's saying that the number on the left-hand side is equal to the number on the right-hand side. So the absolute value of 2a minus 1, in order for us to be able to use this equal sign here, these two, this side here and this side, have to be the same. So 2a minus 1, the absolute value of 2a minus 1 has to be equal to 7. So what we're going to do in order to solve this is, we have a choice for this number in here, right? Either the absolute value of 7 equals 7, or the absolute value of negative 7 equals 7, right? So there's two options for our answers there. So in order to make this statement work, this 2a minus 1 right here, without the absolute value sign, has to either be equal to 7 or negative 7, right? Because then when we take the absolute value, we get a positive 7. Well, that being the case, 2a minus 1 equals 7, which is what we have right here, or 2a minus 1 equals negative 7. Because then when we take the absolute value of it, we get our 7. That's the stuff that gets kind of confusing, is, wait a minute, why is 2a minus 1 7 or negative 7? That's not here. Okay, we're not looking at the right-hand side. We're looking at what are possible answers for inside this absolute value sign. So 2a minus 1, if it's negative 7 and we take the absolute value, it gives us 7. 2a minus 1 equals 7. The absolute value is going to give us 7. So what we end up having to do, Maddie, is solve for this, and then solve for this. So if we do that, we have 2a minus 1 equals 7, 2a equals 8, a equals 4. So one of our answers for a is 4. If we put a equals 4 in here, we get 2 times 4 is 8, minus 1 is 7. Works. Then we also have to do this one here. So 2a equals, we're going to add 1 to both sides, negative 6. So A also equals negative 3. And when we take our negative 3 and put into there, we get 2 times 3 is 2 times negative 3 is negative 6 minus 1, negative 7, absolute value 7. So it works as well. So when you're dealing with absolute values, you're not necessarily only going to get one answer. Sometimes you do, but sometimes you don't. You won't get more than 2 answers, but you're going to get either no answers, 1 answer, or 2 answers. And I'll show you in a minute how you can get less than 2 answers for your problem. But right now, what you're doing is taking it, setting it equal to my 7, and the opposite of that, in this case, negative 7. Okay, so this one's a little bit different in that we not only have an absolute value on the left-hand side, but we also have a plus 5 there. Okay, so because we have a plus 5 there, we're going to have to make a little bit of a change in what we're doing. And that means before we solve these, you've got to get everything except the absolute value on one side by itself. So what we're going to do, obviously, is we're going to subtract 5 from both sides to get it over on the other side so that we're left with only the absolute value. So that equals 12 minus 5 is 7 there. Okay, let me put the other side there. All right, so now that we have the absolute value isolated all by itself on the left-hand side, then we can get started. So then we've got 2/3 x minus 3 equals positive 7, and 2/3 x minus 3 equals negative 7. Okay? And then we solve for both of these, and we find out that x equals negative 6 over here when we do the math. I'm just looking at the book and seeing what the answer is. And x equals 15. So for both of these, if I plug 15 in to that, multiply it by 2/3, subtract 3, take the absolute value, add 5, I get 12. And the same with the negative 6. Okay? So this example is just showing you that when we have something like this plus 5 here, we have to get rid of it so that all we have is an absolute value before we start the problem. Okay. Which brings us to number 4, which is 3x minus 6. And that is equal to negative 4. Okay. So, because that is the case, we know there's no answer because we can't take the absolute value of something and get a negative number. So whenever that number is negative, you're done. You just do this. Null set. No answer. Don't give me 0. No answer. Okay.
When it's negative.
I'm sorry? Yeah. Yeah, when the 4 is negative, yeah. That'll always be the case. All right, which brings me to example 5. And, they start getting a little bit trickier. I guess this is the last example. So this is the only one that's kind of tricky. So the absolute value of x minus 5 equals the absolute value of x minus 7. So what that's telling me is, there we go. When I take the absolute value of the left-hand side, I'm going to get a positive number. When I take the absolute value of x minus 7, I'm going to get a positive number. So the number inside the absolute value sign, x minus 7 could be negative, x minus 5 could be negative, because whenever we take the absolute value, it's going to pop it over into the positive. So that's okay if you get a negative answer. But what we want to do is make sure that when we put a number in here and take the absolute value, and the number in here and give the absolute value, they're going to be equal to each other. That's the key thing that we're looking at here. Okay, so because we've said that they're equal to each other, I can actually say that x minus 5 equals x minus 7, right? Because the number within the absolute value sign has to be equal. Is that true? That's a tough question, because you're thinking, yeah, it is true. What if the number in the first absolute value, when we took x minus 5, what if it gave us 4? And what if the absolute value when we took x minus 7 was 3? Is that possible? No, it's not. What if the absolute value in here was negative 4? Is that possible?
Yeah.
Yeah, it is. So really, x minus 5 equals x minus 7 is possible, because that's like saying that the absolute value of 4 equals the absolute value of 4. But if it is possible for this to be negative, then x minus 5 could equal the negative of x minus 7, right? Because that would give us our negative there. And then when we take the absolute value of our negative, whatever this number is, it'll make it positive, just like the absolute value of negative 4 will make that positive. This is the part that gets a little, confusing. Okay, so the thing that you need to remember, left-hand side equals the right-hand side, and I guess I should say, and the left-hand side equals the opposite of the right-hand side. So it could be 4 equals 4 or 4 equals negative 4. Always the opposite, because when you take the absolute value, they're both the same. Okay, so these are my two options right here. X minus 5 equals negative whatever x minus 7 is, or x minus 5 equals x minus 7. Okay, so let's see if I can erase. I can't erase that either. Doggone it. I'm going to have to figure out how all this...
You have x minus 5 equals x minus 7, or x minus 5 equals negative x.
Negative the quantity x minus 7. So the numbers are the exact same. Whatever's here is over here. It's just this one we didn't take the opposite of, and this one we put parentheses and put a negative sign, meaning we are taking the opposite of. Okay, so that means, it's not letting me erase, it's not letting me get rid of just certain parts of it. It's saying, oh, we want to get rid of the whole thing. So let's go ahead and start this part over in pink. X minus 5 equals x minus 7, or x minus 5 equals the opposite of x minus 7. All right, so let's solve both of those. If we were to look at this, what we're doing is we're taking a value for x and a value for x. Are those x's, do they represent the same number? Yeah, they do, because they're both x's. If one was an x and one was a y, it'd be two different numbers. But whenever your variables are the same, they always represent the same number. So if they're the same number, they pretty much cancel out. We can get rid of that one and get rid of that one and say negative 5 is equal to negative 7. If I didn't cancel those and I wanted to do the math, I'd go x equals x minus 7 plus 5 and get x equals x minus 2. Subtract x from both sides. So 0 equals negative 2. See, it doesn't work when you do the algebra. So that's just kind of a waste of time to do, because when you know that one number is x and the same number over here is x, then these two are going to be equal to each other. So what it's saying is that negative 5 equals negative 7. Is that a true statement? Absolutely not. So therefore, this is not a possible solution. Now, if we did the algebra over here, x minus 5 equals negative x plus 7, and then we add x to both sides, we get 2x minus 5 equals 7. And see how the math is just working? Oops, I'm sorry, 12. And x equals 6. so it works. Over here, it didn't work. When you did the algebra, the x's canceled out, and you ended up with, really, what the heck? I don't know what's supposed to be going on here. That's because it doesn't work. It's not supposed to work. So really, instead of having two answers like we did before, the absolute value of -4 and the absolute value of 4, two answers equal the same thing. Because this didn't work, we only have one answer here.
I thought we were just supposed to kind of like guess which numbers before we figured it out.
Yeah, that'd be kind of rough, wouldn't it?
Yeah.
Because you look at this, you look at the x minus 5 and the x minus 7, if they're equal, what number can you put in for x that when you subtract 5 from it, you get the same thing as when you subtract 7 from it? There's no such answer. You know, you can't take 4 and subtract 5 and 4 and subtract 7 and think you're going to get the same answer. So you can just look at that and know, oh, okay, this is screwy. It's not going to work. So throw it out. And then try the opposite and it'll work. Okay, so that's basically it for this lesson. And I have, again, in my book, 1 to 57 odd. You might want to go to the website and make sure that's right.